Okay, for what we have in problem number 1, we're looking at writing out logarithmic and exponential equations. And we have in number 1, part A, okay, we're looking at rewriting 4 to the third is equal to 64 in logarithmic terms. And now, looking at the relation between what we have for exponents and logarithms, okay, we have y is equal to the logarithmic base a of x, if and only if we have x is equal to a raised to the y. Okay, so for what we have for x, a, and y, we're looking at the exact same terms. This is the logarithmic statement, and we have the immediate corresponding exponential expression. And now we have in part A, we have with 4 to the third is equal to 64. If I write this with the exponential base explicitly given to the y power, I have that 64 is equal to 4 raised to the third power. So you're going to have in the layout, okay, so you have like x is equal to 64, and you have your base a is equal to 4. And for y, we have is equal to 3. And rewriting what we have here in terms of y is equal to the base a logarithm of x. So we have, in this case, we're going to have that 3 is equal to the base 4 logarithm of 64. You can also write this as the base 4 logarithm of 64 is equal to 3. And in looking at what we have in correspondence, okay, so we have, okay, so you have the base 4 logarithm, okay, so you have that logarithmic attachment on the left hand side, so you have the base 4 logarithm of 64. Okay, so you have the base 4 logarithm of 64 is equal to 3. Now, rewriting what we have as an exponential function, so you have the base 6 logarithm of 1/6 is equal to -1. Okay, and we have, in this particular setting, notice we have y is going to be represented by -1. And we had base a logarithm, we have a is equal to 6. And for x, we have for 1/6, okay, that will be in reference to x itself. And if I reconfigure and write in terms of x is equal to a to the y, okay, it's going to follow that we have that 1/6. Okay, and we have is equal to a to the y, so 1/6 is equal to 6 to the -1. Or you can also write in the commutative property of equality equivalent terms, have 6 to the -1 is equal to 1/6. So we have in part B, okay, so we got 6 to the -1 is equal to 1/6. And upon checking, and the result is correct. Okay, now for what we have in the second problem, okay, and we were looking at rewriting as logarithmic equations. So we have e to the 8 is equal to x, and the natural logarithm of 7 is equal to y. Okay, and so setting up what we have here for number 2, okay, so we have e to the 8 is equal to x. And let me just mention, okay, so we have, so e is going to be the natural logarithmic exponential base. And what I want to do here is I want to get out of the exponential base e. So I'm going to take the base e logarithm of both sides. So I'm going to have that 8 is equal to the base e logarithm of x. And remember, e is a natural logarithmic base. So base e logarithm, okay, that is going to be a natural logarithm. So I can say that 8 is equal to the natural logarithm of x, or that the natural logarithm of x is equal to 8. So filling in, okay, so just drawing what we have here. So we have the natural logarithm of x is equal to 8. Now, in the case of the natural logarithm of 7 being equal to y, okay, now natural logarithm of 7, that's going to be a base e logarithm. And to get rid of base e logarithm, I'm going to take the exponential base that matches. And so for what we're going to have here, taking both sides as powers to which the exponential base e is going to be raised e to the base e logarithm of 7. Exponential logarithmic bases cancel out that they're identical. So we had that 7 is equal to e to the y, or we can say that e to the y is equal to 7. So filling in, so you have e to the y equals 7. Upon checking out, and the result is correct. Now, for what we have in the case of the third problem, okay, and we're looking at rewriting as exponential equations, okay, and so in taking what we have now, okay, if I rewrite as an exponential equation, so I have the base 3 logarithm of 81 is equal to 4. And if I rewrite as an exponential equation, what I can do is I can get rid of the logarithm base 3 by applying the exponential base that is going to match. So I had in this case, I have 3 to the base 3 logarithm of 81. This will go to 81. And we have the 81 is equal to 3 to the 4th. Okay. Or 3 to the 4th is equal to 81. And for what we have in the next item, okay, so we have 8 to the negative 2 is equal to 1/64. And if I convert from exponential to logarithmic base, okay, so I have 8 to the negative 2, and what I can do is I can free up the negative 2 by taking the base 8 logarithm of both sides. So I have the base 8 logarithm of 8 to the negative 2. Okay, so we have left-hand side becomes negative 2. And we have negative 2 is equal to the base 8 logarithm of 1/64. And just for the commutative equivalent, we have the base 8 logarithm of 1/64 is equal to negative 2. So we have in checking, and we have for the end result, okay, that is correct. All right. Now, for what we have in the case of number 4. Okay, so looking at rewriting as an exponential equation, now we have the natural logarithm of 9 is equal to y. And again, natural logarithm is another way of saying log base e, or base e logarithm of 9. Okay, so I have the natural logarithm of 9 is equal to y. Natural logarithm, that is a base e logarithm. And I can just say that I had the base e logarithm of 9 is equal to y. And if I get rid of the logarithmic, so I can apply the exponential base e to both sides. E to the base e logarithm of 9 goes to 9. And we have that 9 is equal to e to the y. Now, if I rewrite as a logarithmic equation, what I have in part B, I have that e to the x is equal to 3. And if I get rid of the exponential base e, I can apply base e logarithm of e to the x is equal to the base e logarithm of 3. Base e logarithm of e to the x goes to x. And we have x is equal to the base e logarithm of 3. And a base e logarithm is going to be a natural logarithm. So I have the x is equal to the natural logarithm of 3. So just plugging in what I have here, so I have 9 is equal to e raised to the y for part A. And for part B, I have x is equal to the natural logarithm of 3. And we have in checking. And the result is correct. Now, for what we have in number 5, we're looking at evaluating expressions. And for what we have in parts A and B, now we have a base 7 logarithm of 49. And this can be reduced to a constant since 49 is both a multiple and a power of 7. And 49 is going to be 7 to the second. So here the 7's are going to cancel out. So you have matching exponential and logarithmic base. And this will reduce to the exponent, which will be at 2. For the base 3 logarithm of 1 over 81. Now 81 is both a multiple and an integer power of 3. Now 81 we have to be, in this particular case, that's going to be 3 raised to the 4th power. Now we're looking at the reciprocal. So we're not looking at the base 3 logarithm of 3 to the 4th. Instead we're looking at the base 3 logarithm. And the reciprocal of 3 to the 4th will be 3 to the negative 4. And so we have for part B, this will go to negative 4. So we have the base 7 logarithm of 49. Okay, so that will go to 2. And the base 3 logarithm of 81. Okay, so that's going to go to negative 4. And checking out. And the result is correct. In number 6, okay, so looking at reducing, now we have the base 6 logarithm of 6. Now, you have base 6 logarithm of 6. Now, there is no explicit power that is given, but you could read this as if it were the base 6 logarithm of 6 to the first, where the 6's will go out, and the result ends up at 1. Now, for part B, we have the base 4 logarithm of 1/64th. So we have the base 4 logarithm of the reciprocal of 4 to the 3rd. And again, we're going to have the base 4 logarithm and the reciprocal of 4 to the 3rd. If I write in direct terms for the exponential base, okay, this will become 4 to the negative 3. So the base 4 logarithm of 1/64th, okay, that is going to go to negative 3. So again, for part A, okay, we have it 1. Part B, we have it negative 3. And checking out. And the result is correct.